All right, our first lesson talked about just regular functions and relations. So this lesson we're going to talk about a specific type, linear functions and relations. So I have two sides here. First side, linear functions have a constant rate of change. The other side, we'll talk about things that are not linear. Okay, so a constant rate of change, what does that mean? So if I give you a table of values or a set of points or anything, when you find the changes in between the x's and in between the y's, when you divide those two numbers, they should be constant. So I'll show you what I mean. The change between 1 and 3 is 2, between 3 and 6 is 3, between 6 and 10 is 4. All right, between negative 4 and 0 is positive 4, 0 to 6 is 6, 6 to 14 is 8. All right, so it doesn't look like anything is constant here. Everything's changing. But what's constant is if I do the change in the y over the change in the x, then you get a constant. So that's going to be 4 over 2, which is 2. This one is 6 over 3, which is also 2. And 8 over 4, which is 2. All right, we talked about slope a little bit at the very beginning of the year. How's the changes in the y over the changes in the x? Delta y over delta x. Okay, so that's what you're looking for to determine if something is linear or not. Okay, sometimes they give you an equation. So what are you looking for in an equation? Okay, a linear equation, the variable must be raised to the first power. Okay, and usually we don't even write the first power. So it's got to be just an x by itself. Okay, and it must not be acted upon by any other function. So you can't have a square root around the x. You can't have an exponent around the x. No other function. The only thing that you can do to it is multiply it by a constant. So some examples of equations that are linear. Y equals x plus 2. Y equals 7x minus 4. Okay, so it's just an x by itself, no exponent, no other weird function. The only thing you're allowed to do it is multiply it by a constant, like 7. All right, so over here on the right, nonlinear functions do not have a constant rate of change. So if we go do the same rate of change thing over here, I get 2 to 0, negative 2 to 0 is plus 2, and then another plus 2, and then a plus 3. All right, and this one is plus 5, another plus 5, and another plus 5. Okay, so it's looking like it's going to be linear, right? We've got 5 over 2 for the first one. Second one is also 5 over 2. But that third one, you see it's 5 over 3. And right there, if even one of them is off from the others, then it's not linear. Okay, so this would be some sort of nonlinear function. If it's even a function at all, it might just be a relation. All right, so variable in a nonlinear equation would be raised to a power other than 1. So something like y equals x squared, not linear. Y equals x cubed, any exponent makes it not linear. Some other things that you might see, it could be multiplied by another variable, y equals xy. That wouldn't be linear. Under a radical is a square root, so y equals the square root of x is not linear. Denominator of a fraction, y equals 1 over x. Even though x is only raised to the first power, if it's in the denominator of a fraction, then it's not linear, it's something else. All right, is an exponent of another variable. So like y equals 2 to the x. If it is the exponent, that's not linear, even though it's raised to the first power. All right, as well as inside a logarithm. So you might have seen logs in science, log of x, like that. Okay, none of those things would be considered linear. So there's a bunch of different types of functions. We're actually going to cover every single function that I've written down here just now, except for maybe the xy. And y equals xy doesn't really make sense. It would be more like 7 equals xy. So that's pretty much the only one we don't really talk about too much. But all these other ones we'll see this year as we go through the rest of our year. All right, so standard form of a linear equation, we need to be able to work with standard form, be able to transform it out of standard form. Sometimes you want it transformed into standard form. Okay, so standard form is ax plus by equals c. A, b, and c have to be integers. So there's one of those buzzwords from our last unit. Okay, remember integers are positive and negative whole numbers. So no fractions, no decimals in standard form. Okay, they also have to have a GCF of 1. So if you have like 2, 4, and 8 as your numbers, you have to divide them all by 2 to get it down to 1, 2, and 4. All right, so they have a GCF of 1. And A is not allowed to be negative. You have to have A be a positive number. All right, so let's try this out. We have an equation here, linear equation. Okay, it's not in standard form. This is actually in slope-intercept form. We'll get to that later, though. So let's transform it. The thing I see is I need to move the x over to the other side. So I need to subtract 3x. X and y have to be on the same side of the equation. So negative 3x, that's a positive y, so plus y equals negative 9. Okay, make sure we're following the rules. Are they integers? Yes. Do they have a GCF of 1? Well, the number in front of y is a 1, and since 1 can't be divided by anything else, then yes, they have a GCF of 1. Is A positive? No. All right, so to fix that, we need to multiply the entire equation by a negative. So it's going to distribute to all three terms. So negative times a negative makes that a positive 3. Negative times a positive makes that a negative y. Negative times a negative makes that a positive 9. So basically you just go through and switch all the signs and then you're good to go. All right, y'all give this next one a try, see if you can come up with the right answer. Unpause the video and see if you got it right. All right, so on this one we're going to have to add 6x over here. And we'll get 6x plus 2y equals 12. All right, are they integers? Yes. Do they have a GCF of 1? Ooh, I don't think so. All right, if you see 6, 2, and 12, they're all divisible by the same number. We can divide everything by 2. So if you see that they're all three divisible by the same thing, you have to do that. So 3 divided by 2, or 6 divided by 2 is 3. 2 divided by 2 is 1. So we don't have to write 1, you can just write y. And 12 divided by 2 is 6. So 3x plus y equals 6. All right, let's check this last one. Okay, again, we have the x and y on opposite sides, so I'm going to move the x term over. All right, so I've got negative 3/4 x plus 1/3 y equals 4. All right, are they all integers? No. Okay, when fractions are not integers, so we have to get rid of our fractions on this one. Okay, so I want to multiply through by the least common denominator. Okay, by one single number that's going to cancel out both a 4 and a 3. Okay, so that number in this case is 12. Okay, if I multiply through by 12 on all three terms, that's going to cancel out both denominators and leave me with all integers. All right, so remember how we kind of talked about this. 12, and I'm going to do divided by 4 first. So the 4 is going to cancel. 12 divided by 4 is 3. 3 times negative 3 is negative 9x. All right, this one, 12 divided by 3 is 4. 4 times 1 is 4y. And then no denominator on this one, so I just need to multiply these together. 12 times 4 is 48. All right, do they have a GCF of 1? Yeah, it doesn't look like I can divide everything by a single number. So we're good to go there. Is A positive? Nope. So I need to finally multiply through by a negative, and that's just going to switch all of our signs. Positive 9x minus 4y equals negative 48. All right, last one, find the x and y intercepts. Okay, so first thing I'm going to do, has some weird fractions in it. This is still actually linear, even though it looks like it wouldn't be, because all we're doing is multiplying x by a constant, 15 over 4. All right, y is only multiplied by a constant. All right, so first thing I'm going to do is get rid of the fractions. So again, I'm going to multiply by an LCD. In this case, it's going to be 20. 20 is the number that can be divided by both 4 and 5. Okay, so 20 divided by 4 is 5, and then I need to distribute that 5. So 5 times 15 is 75x. 5 times 20 is 100. All right, 20 divided by 5 is 4, and then distribute the 4. 3 times 4 is 12y. 6 times 4 is 24. All right, then I'm going to get it in standard form, so I'm going to move the 12y over. 75x minus 12y plus 100 equals 24. Let's move the 100 over here. 75x minus 12y equals negative 76. All right, so how do we find the x and y intercepts? So I like to do what's called the cover-up method. All right, the cover-up method basically says if we want to find the x-intercept, we know that y has to equal 0. So I'm going to cover up the 12y part. Now pretend that blocked it completely. So what's left over of this equation? I have 75x equals negative 76. Okay, so you solve that equation, and whatever that is your answer. So 75x equals negative 76. So I divide by 75. So the x-intercept is negative 76 over 75. And if you want to be really technical about it, you should write it as a point, because it's something that we are going to put on a graph eventually. Negative 76 over 75, comma 0. This is our x-intercept. All right, and then you use the same strategy for the y-intercept, except you're going to cover up the 75x. And what's left over, so again, pretend that's disappeared, negative 12y equals negative 76. All right, so let's solve that equation. All right, so we're going to divide both sides by negative 12. So we get y equals positive. And 12 doesn't go into 76 evenly, so we can just reduce this fraction. Okay, they are both divisible by 4. So if you divide the top and bottom by 4, 76 divided by 4 is 19, and 12 divided by 4 is 3. So the y-intercept would be 19 thirds, and if we write it out as a point on a graph, it would be 0, comma, 19 thirds. All right, so those two are kind of ugly. Most of the time when you're doing x and y intercept, especially if I'm going to ask you to graph it later, they'll come out to be a little nicer numbers. You might still get fractions, but it'll be like a 1/2 rather than a 19 thirds, which is kind of a weird one to graph.